Okay, so I should ask the question whether y'all were able to watch that video that I sent on the Simplex method. Anybody watch the video? Not hearing anything.
Sure, not as yet.
What? So how you gonna understand the tutorial? How you gonna know what's going on? You're all good, you know, you're all good. Man. Right. I'll do a few examples nevertheless. So we're doing this one. You're looking at this one here. Give me a second. Number 3 here. Right. So we're gonna start with a simple one that you can actually solve. You can actually solve geometrically with that graph, right? And then we'll transition to one that the graph might not be able to solve. And therefore, you have to use the simplex method, right? So it's this one I'm talking about. So they're telling you that a farmer has 100 acres of land. So that's a constraint right away there, 100 acres only. And he wants to grow wheat, corn. And they're giving you some more details here that each acre of wheat requires 4 hours of labor and $20 of capital. And each acre of corn requires 16 hours of labor, $40 of capital. And this is the constraint. He only has 800 hours and $2,400 in capital. Right? So you want to know, well, if he can make $80 on an acre of wheat and $100 on an acre of corn, how can he maximize his profit, right? So let's see. We can make up our. Let's start with what we start with some variables, right? So let x be the number of acres of wheat, right? Let y be the number of acres of corn, right? So you already see a constraint there. The two must not, x plus y must not exceed 100 acres. So that's constraint number 1. Another constraint, I think it says 4 hours of labor and $20 for of capital per acre for wheat. So that'll be what? 4 that'll be what? 4x. How much it um 16, right? 4x plus 16y must not exceed 800. That's another constraint. And then what's that? $20 for wheat. 20x plus 40y must not exceed 2,400, right? Good.
Yes, sir.
What we're going to do, we're going to use the simplex approach. To solve this. And then we'll also look at the geometric approach to it, where we use the graphical approach to see if the two giving you the same answer, right? Oh, and our objective function or profit function is going to be what? $80 for every acre of wheat. So that's what 80x plus $100 for every acre of corn. Right? This is your objective function. We want to maximize this, right? Everybody's following so far? You agree with what I'm saying there?
Yes, sir. Following so far.
So please take a note maybe of these here. I'm going to go over. I have to stop sharing. I think. I have to stop sharing and go over to, because I'm not going to do this by hand. I have to be crazy, right? Give me a second. I'll go over to see if I can find. One second. I'm trying to type in the give me 1 second. Good. So I'm using a matrix, a simplex calculator, in fact. Right? I'm giving you all of this detail. This one is from emathhelp.net. They have plenty, right? This is just one of them. I'm not thrilled, and I don't like this one the best, but nevertheless, it works, right? So yeah. So here is our problem, right? You type in your objective function. You type in your constraint there. Yes, all variables now negative. Using the big M method. And I can now calculate, right? I hope I didn't really want anything wrong. Yes, good. So they're telling you, well, okay, this is what you put in, right? So you're going to solve now. So remember we talked about putting in some slack variables. We don't want to have inequalities in the relationships anymore. So we're going to put in S1, S2, and S3, right? Put in some slack variables, you call it. Good. So you take all of this information now and notice what we do, right? We normally take the 8x and the 100y over the equal sign where the z is. And they become negative, right? So S1, S2, S3, 0, okay. Where is this one? Okay, look here. The coefficient here is 1, coefficient here is 1, coefficient here is 1. So you get 1, 1, 1. There are no S2s and S3s in this force equation here. Equal to 100, then you put S2, right? So you get 4, 16, and 1, 4, 16. No S1, you got an S2, you got a 1 there. No S3, and you put it equal to 800. Then for this one, 20, 40, no S1 and 2, only one S3, right? Different writers are going to formalize their matrix a little differently, and their tables might be a little different. I think the one in the video I showed you, this Z column, this Z row here is at the bottom, right? The Z row is at the bottom. This writer, this website, has it on top, right? They put the objective function on top. The one in the video is at the bottom. But that's not a problem. That has nothing to do with the problem, right? Good. So what's your first step? Notice you are going to identify the most negative number in the Z row here, right? You see it's minus 100, right? You're seeing that?
Yes, sir.
Good. So that's what we call it, the pivot column, right? Take the pivot column, and what do? You divide the 100, the 800, and the 2400 by the 1, the 16, and the 40. And the one with the lowest ratio, which is the 50 in this case, will help us now to identify what we call the pivot row, right? So if I annotate, I have to erase everything very often. So this is our pivot column. This is our pivot row, right? And what's going to happen in the next table is that you're going to replace this S2 with Y, right? So I have to erase that again. What do we do now? We want to make this pivot number, this 16. See this here? We want to make this 16 into a 1, right? So scroll up. So what do? We divide the row by 16, right? Notice now that your S2 down here, right? Your S2 down here, your S2 is replaced by Y, right? As you start looking for a basic solution, right? See my basic here? So you get your 1 here. And what you need to do now is you need to make this into a 0 and that into a 0, right? And here is where you're going to put what we call row operations to work, right? So what do? They say add row 3 multiplied by 100 to row 1. So they take this row, right? Take this row, multiply it by 100 and add it, right, to row 1. So that would make this number here 0, right? But if you take what? I mean, you have to take all these numbers, but I'm looking at this first one. If you take this and multiply it by 100 and then you add it to that, you'll get 0, right? Good. So that's what they did here. They did it. We got our 0 here, right? Our next step is to make this one here. This one, we have to make this one here into a 0, right? Let's do that. So what do they say? Subtract row 3 from row 2, right? So you just subtract this row from that row, right? Quarter from 1, 1 from 1, 0 from 1, and so on and so on. You replace this row now with the result, right? And we get what? You see what happened here? We got 3/4, 0, 1, minus 1, 16, and so. So we do have our 2 zeros above there. Our last step now is to get rid of this 40 from here. I want to make this into a 0, right? So what do they suggest we do? subtract row 3 multiplied by 40 from row 4. So you take this entire row, multiply it by 40, and subtract it from this row. And you will get 10, 0, 0, minus 5021, 400, right? And now we have what we desire. We have our 1, where our pivot element was, and zeros above it and below it. You repeat the procedure now, the same procedure. You look in your Z row, look for the most negative number. In this case, it's minus 55. And you repeat that same procedure, right? So you go there, look what we do now. We take the column. We divide each of these numbers, the 50, the 50, the 400, and so by the number in this column here, right? You don't have to divide 5,000 by the minus 55. No. You're only doing it for these numbers here, these rows. So when we divide, we got what as the lowest here? 200 divided by 3. 40. 40 is the smallest one. So this becomes our pivot row now. So we have our pivot column. Now we have our pivot row. And you see this 10 here, you have to make it into a 1 now. How to do it? Divide by 10. That is what happens there. So, and by the way, the X that you see here, the heading here, will replace S3. Right? Replace S3. So when we do that now, we get our X here now, right? So X here. And we get our 1. So what we got to do now, we got to make sure that this quarter and this 3/4 and this minus 55 almost become 0. How do we do it? Well, let's see. You add row 4 multiplied by 55 to row 1, right? So you take this entire row, multiply it by 55, and you add it to this row, right? And you will get these numbers. You get 0, 0, 0, minus 15 over 2. And that is why I'm impressing upon you the need for a calculator of this sort, right? Don't go do this by hand, you wouldn't finish, right? You have to have a calculator like I'm using. Good. Our next step is to get rid of this 3/4 and the quarter above there, right? How? Well, again, they describe it to you here. They describe it to you there. I don't have to go through this, right? So when we have done all of that, right? We now have to tackle what else is negative. Oh, we have minus 15 over 2. Right? So, yes, minus 15 over 2 is negative. So that's our new pivot column. And we continue the same process, right? We divide all the numbers here now by the 1/8, the 1/8, and the minus 1/4. And we see the smallest, we have a negative denominator. Well, as they tell you, ignore it here. And you use the 160, right? You don't want a negative ratio. So you take this one, and that will tell you now, oh, this is your pivot row. And your pivot element is 1/8. So you now have to try to make that into a 1, right? And that's what you did here. Look here. You make it into a 1. And what you have to do next? You have to make these numbers above and below zeros, right? And now you do that. Well, they explain all here, right? You're going to rewatch this video, slow it down, and follow the row operation that they do here, right? Here and here. And eventually you got, okay, you got 0 here, you got 0 here, you got to get a 0 here too, right? And you do another step and you got a 0 there. So here you have 0 above and below the 1, right? Good. So basically, in your Zen row now, there's no negative number. So when that happens, the optimum condition is reached. And your answer is, notice, X. Well, you don't have to worry the S and so, right? So your answer is X is 80, Y is 20, and your maximum value is 8,400. Right? So your maximum value is 8,400, and it happens when the person plants 80 acres of wheat and 28 acres of corn. And we're going to check this in just a moment on, what do you think, name? Desmos. Right? So the hardest part of this thing is take the problem that we had at the beginning, form your inequalities. When you finish forming the inequalities, bring them over to a calculator, a simplex calculator. Enter all your constraints, enter your objective function, and let the calculator do the job, right? However, you must know the process because I could formulate questions that involve the process. I've been explaining the process every time, right? And the simplex calculator will look, they calculate right down to when the optimum condition is reached. And they read off the answer. Look, the answer is watching you in the face, right? So we're going to take this now over to Desmos. I think I can actually, what if I see? Let me see. I'm switching to Desmos. Tell me if you're seeing Desmos. Are you seeing Desmos?
Yes, sir.
Great. So I'm going to enter the same inequality. Let's see. What will be? X plus Y must be less than 100. What's the next one? 4x plus 16y must be less than, was it 800? And what is it? 20x, 20x plus 40 must be less than 2,400. Right? So let's see if we can. Okay, right. And they told us that the answer lies at, and you can try these are the points, right? This point here, that point there, that point there, this point here, and this point here. Oh gosh, what happened here? Right? But if I click on the origin, it gonna mess up the whole thing. So this is the feasible region, really. And I think one more thing I can do. I put in the profit function. What is the profit function? Taking x plus 100, right? Equal to, what was the value? 8,400 equal to 400. Right? So that black line there, yeah, tells you that when, yeah, that's the maximum value you can take. And you can try those numbers, right? Let me take off this, take off that. So this was a point. That was a point. This was a point. And this was a point, right? You could try these numbers inside the profit function, and you will see that 80-20 is going to give you, right, your highest profit. So the simplex method actually agrees with the graphical approach, right? Good. Now, notice in this problem, you only had X and Y. What when we have X, Y, and Z? What happens now? Right? So I'm going to go back to this here. Yeah. And here it is. Look here. Look at question 4. Can you see question 4? A factory manufactures chairs, tables.
Yes, sir.
So look at that problem. So here we have 3 operations, not 2. We're not planting wheat and corn alone. You're doing here cutting, you're doing assembling, and you're doing finishing, right? So we have 3 things to do. One would suspect now we'll have 3 unknowns, right? So let's see what they're talking about. Those are the operations. They're making what? Chairs. What else? They're making tables. And they're making bookcases. Okay. But so all of that information you're seeing there, I'm not going to read it. You got to read it. And let's make the inequalities from them, right? So in all, okay, we have to declare some variables for us, right? So let me see if I can. Yeah. Let me see if I can fit them. So let, I'll fit them right here. Let X be the number of chairs, right? Chairs made, right? Or manufactured. Let Y be the number of, what is it, tables? What's happening? Tables. Let Z be the number of what is it, bookcases, right? Right. When we look at that information, what are they saying? Let's look at how many hours you have for cutting. So the first operation, 600 hours. That's cutting, right? So a chair requires 1 hour of cutting. What a table? A table needs 1 hour of cutting. And a bookcase requires 3 hours of cutting. So if you were to write that, X plus Y plus 3Z must be less than or equal to 600. Right? Then let's go to finishing, right? Not finishing, sorry, assembly now. A chair needs 1 hour of assembly, so that's X plus or 1X, right? If you're making X chairs, 1 times X will give you the number of hours you spend assembling a chair. Where is the table? Table needs 2 hours of assembly. So if you make Y tables, 2Y plus, what about bookcases? Bookcases need 1 hour of assembly. So plus one Z or Z, right? And that must not exceed how much? 500 hours? 500 hours. And lastly, a table requires 1 hour of finishing. Okay. How many hours for? No, a chair needs 1 hour of finishing. A table needs 1 hour of finishing too. And how much for a bookcase? 1 hour too. Okay. All of that must not exceed 300 hours, right? And our objective function or profit function is going to be 20x plus 31 plus 25z, right? Now you make $20 on a chair, $30 on a table, and $25 for a bookcase, right? So we're going to go over to our calculator and input all of this, right? I think I might have to erase this. Yeah, I think so, because it might show up. Let me see. I'm going over to this one right here. Yeah, I have to erase all this stuff. So all that information I already input on this calculator, right? But that will take a long time if I wait for the class, right? So here it is. So here's my objective function. Here are all the constraints done, put in there, right? And you calculate, right? So you calculate. So here they're throwing some slack variables, S1, S2, S3. They make up the table there. Please note how they make it up. Again, I'm telling you, this calculator puts the objective function in a row at the top, not at the bottom like in the video. And then, you start looking for your pivot column, which is the minus 30, that's the lowest, or the large, what was it, the most negative number, right? And then you do your division to figure out which has the smallest ratio, and that will be your pivot row. And the 2 becomes your pivot element, and you make that 1 and all the numbers above and below zeros by doing row operations. If you follow what's going on here, right? When you go back to the video, right? So you want to make 2 into a 1, you don't divide the row by 2, right? And you get a 1 here, right? But all the rest, whatever it turns out to be, it turns out to be, right? Good. And notice that you replace S2, that's the variable that is leaving. You're kind of throwing out the slack variables one by one. And you're moving into your solution when you move over Y to where S2 is, right? Notice that. Good. So your next objective is to make this minus 30 here into a 0. You have to make this 1 here into a 0. And you have to make the 1 at the bottom here into a 0, right? And the row operations. So they're doing it 1 by 1. Doing this one. See, they get a 0 there now. And they're telling you how to do it, right? They're telling you how to do it. Then you want to make this one 0, and then this one 0, right? So notice they make it 0 here, and they tell you how they're going to do it by a row operation. And lastly, you want to make this one into a zero. Notice again how they do it, right? After that, you repeat the process. You know, you look for the most negative number. It's -10. That becomes your pivot column. You do your division, as you see here. The lowest number here is 100. Therefore, your pivot element becomes a half, right? And then you have to now make that, right, into a 1, and everything else around it, right, above and below. Well, there's nothing below, it's above. You have to make into a 0, right? So that's what they're doing there. They make it into a 1, right? And then they're going to make all of these now into zeros, right? And one by one. They're showing you the row operations that you can do. Another row operation. Another row operation. Right? And what happened now, you notice there are no more negatives now in the Z row. No more negatives. And that tells you that you have reached the maximum or the optimum condition, right? What's your solution? Notice. You notice in your solution here, you don't have no x, no x. You have a y and a z, right? So your answer is your maximum profit is going to be 8,500, and it's going to be achieved when you don't make any what's that? Cheer, right? X was cheers. No cheers. Don't make no cheer. You're running on the business. You make 200 tables and 100 bookcases, right? And that's your answer. You make up your inequalities, you bring them over to the Simplex calculator, let it do the job for you, and you get your answer at the bottom. Anything making sense to you? I hear no comments.
Yes.
Tomorrow, let me see, tomorrow, before the week is out, I'm going to send you some of these notes, like, because I'm going to cut the whole thing so that you can at least follow it. Sometimes watching a video might help. But as I said, don't do this by hand. You're not going to finish. Let a calculator do the job for you. Good. So I want to do a last one that involves minimization, right? So I'd have to stop sharing for a moment to go over to that, right? Give me 1 second. So give me 1 second. Good. So here, how do you do minimization problem? We've been doing maximization problem over and over and over, but never, we're doing minimization problem. So there is well, somebody came up with this idea. I think the name is here. What is it? Dr. John von Neumann. He came up with something called, wait, let me see what the name of it is. The duality principle. So here is what he did. He said if you have something to minimize, right? Now, instead of using or having to do, especially simplex, right? This one is you can solve it using a graphical approach very easily. However, before you do that, right, what you can do is take the objective function and the constraints, right, and create a matrix and form the transpose, right? So look at what is happening here. Where is it? One second. Yeah, look here. Okay, right. So you want to minimize z equal 12x1 plus 16x2 and so on. And these are the constraints, right? You want to minimize that. So you write them as a matrix here, right? So you put your 1, 2, your 1, 1, put your 40, your 30. Then you write this now, 12, 16, with 0 at the end here, right? Good. Take this matrix and find the transpose. Right? So you notice 1, 2, 40. This first row becomes the first column. The second row becomes the second column, and the third row becomes the third column. Now, this problem now becomes what they call a maximization problem. So your problem becomes z equals 40y1 plus 30y2, right? You're not using x. Subject to, and you're going to use now 1, 1, 12. Notice it's y1 plus y2 is less than or equal to 12. And then 2 and 1 and 16. 2y1 plus y2 is less than or equal to 16. Well, these non-negativity conditions are always there, right? But we know how to do this. We know how to do this, right? We know how to do this. So we solve that, right? We solve that. We can use the graphical approach or we can use simplex, right? And I think that's what they did here, right? They solved the thing. So to minimize this, the solution was this, right? If you use the graphical approach. If we take it and transpose it and we turn it into a maximum problem, we'll get the same answer, right? Watch. We'll get the same answer of 400. However, notice the corner points is 4 and 8 is a different corner point, right? Keep that in mind. So when we use the simplex approach, right? If you use it, well, that's what they're doing here, right? You use the simplex approach, right? What they did here, they introduced x1 and x2 as what we call slack variables, right? Yeah, x1 and x2 are the slack variables. They do their simplex solution, and they get the same answer. Watch. The minimization problem has a minimum value of 400, and the corner points are 20 and 10. Right? Of course, this is a different way they do it here, right? But if you put it in the calculator, we just use it, it will give you the same answer. You think you follow that? When you have a minimization problem, right? Let me go back that part. You have to minimize this, right? That's, yeah. So you have to minimize this, right? Now, in this case, it only involves two unknowns, x1, x2. A graphical approach will easily solve it. My point is, if it involves three unknowns, x1, x2, and x3, you will not be able to use a graphical approach to solve it. You will have to use simplex. However, doing a simplex or using the simplex method with minimization is a very difficult process. It is not as simple as the maximization process. Therefore, what you want to do is to transpose the minimum problem into a maximum problem. How? Write out the conditions, the minimization condition as a matrix and transpose it. And when you get this, okay, so this here, you make up based on that. Transpose this and you get this. And then formulate a new maximum problem, right? Don't use X. You notice above had X1, X2, X3. Don't use that. Use Y1, Y2, Y3, and so on. And use a simplex calculator now to solve this, because we already have a simplex calculator to solve this. Mind you, that simplex calculator showed you earlier can solve the problem as a minimum, but you might not get the steps. The steps involve some extra stuff, right? You can put that minimization problem in the calculator and it will do it for you. However, you will understand the process if you use if you turn the minimization problem into a maximization problem and then use the calculator, right? And when you do that, you will get the same answer, right? You'll get the same answer. Oh my. Good. So as I said, I'll send you a few more notes. Maybe I'll try to cut what I discussed in the tutorial, put them into some notes, and see if it will make some sense to you too, right? So we were able to do a simple two variable simplex problem. Then we do a 3 variable. And here I'm explaining how to turn a minimization problem into a maximization problem and go ahead and use your calculator, right? Your simplex calculator to solve it. Good. So I think that will do it for the tutorial.